Hello everyone, welcome back to our latest video. Today, we're diving deep into the fundamental aspects of Android apps. Our focus will be on unraveling the core concepts that lay the groundwork for Android app development. Every app that we download and install from the Play Store or any other source come with the .apk extension, indicating that they are compressed archive files. These APK files encompass various files and folders, which we'll explore shortly in this video. As we go about our digital lives, it's common to download these apps and set them up by granting the required permissions before diving in. But today, we're shifting our attention to the technical side. We're about to peel back the layers to understand what's tucked away inside these apps, how they're packaged, and the intriguing sequence of events when we hit that install button. Let's start by getting a solid grip on the structure of Android apps. Imagine for a moment the final product that you, as an end user, interact with. As mentioned earlier, Android apps come wrapped in a package denoted by the .apk extension, a shorthand for Android application package. These packages, much like treasure chests, hold an array of files and folders. It's what end users and those delving into penetration testing receive. Given that Android apps are essentially archive files, you can unleash their contents using any traditional extraction tools. This diagram paints a clear picture of the folder structure once the APK file is unzipped. This structural layout is a constant across different APKs, occasionally sporting slight variations like an added lib folder when supplementary libraries are part of the app's ensemble. Let's explain it down with a step-by-step approach to uncompress an APK file. Here, we have a file named test.apk residing in the Kali home directory. The first step is to modify the file extension from .apk to .zip. To extract the contents on your Linux system, open a terminal, use the unzip command followed by the destination directory where you want the uncompressed files to reside. And then mention the name of the zip file you want to extract. If you are on a Windows system, you can use 7-zip, WinRAR, or any other similar tool to extract the contents. After the extraction process, a world of files and directories unfolds before us. These include Android manifest.xml, classes.dex, res, assets, and meta.inf. Now, let's delve into what's hidden within each of these files and folders. Android manifest.xml. Think of this as the app's information hub. It not only houses configuration details but also the app's very identity. From the package name to insights about app components, security settings, permissions requested, and much more, this file is the keeper of app essentials. Classes.dex. Imagine this as the app's translator. It holds the Dalvik bytecode, a transformed version of the developer's source code. When the app runs, this DEX file takes the stage, executing the app's functionality on the device. Later in another video, we'll even explore how to manually create and run this DEX file on an Android device. Resources.arsk. Here, we find the app's compiled resources. It's like a treasure chest of assets that the app requires to function seamlessly. RES folder. Within this folder, you'll find the raw materials that bring your app's visual and creative elements to life. Think of images, icons, and other graphical assets that add sparkle to your app. Assets folder. This folder acts like a secret stash. Developers can tuck away files of their choosing, be it music, videos, databases, and more. These files become part and parcel of the app, bundled together for a cohesive experience. Meta.inf folder. Here lies the app's virtual identity card. Not only does it hold the application certificate, but it also contains the SHA-1 digests of all files used within the app. It's a behind-the-scenes security feature that ensures the app's integrity. By peeking inside these files and folders, we're unearthing the intricate framework that shapes an app's functionality and structure. Lib directory. Inside an Android APK, the lib directory holds special libraries tailored for different device CPUs. These libraries, crafted in languages like C or C++, offer crucial functions that run more efficiently directly on the device's hardware. The lib subdirectories match various CPU types like ARMIA by v7a, ARM64 v8a, x86, and x86-64. Upon installation, the right libraries for the device's CPU are chosen for optimal performance. COM directory. In an APK, you won't usually find a direct COM directory. Yet, it's important to know that Android apps often structure their Java code using reverse domain naming, like comexample.myapp. This arrangement arranges the code in a virtual com/example/myapp structure. This approach avoids clashes in names and logically organizes the app's code. This is all about the fundamentals of Android apps. In this video, we've covered the groundwork by understanding the essential structure of Android apps and delving into what lies within an APK file, as well as how to unzip it. In our upcoming video, we'll take the next step and explore different storage spots for Android apps. We'll even dive into the techniques of extracting both pre-installed apps and those personally installed by users. So, stay tuned for that. For now, it's time to bid farewell. If you have any questions or thoughts about this video, feel free to drop them in the comment section. Until next time, take care and goodbye.